Hey, AP Chemsters, this is Mrs. Vanderbilt again, bringing you the rest of section 13.3. I asked you the last time to actually work on these problems on your own. Hopefully you were able to do that and come up with what I have. If you ever have any questions, write it down, and either Mrs. Blankenship or I can always answer them in class later on. So the first one is determine the rate order. How did I do that? Again, I'm looking at where the rates are held constant. So when I held NH4 constant, what happened here? The concentration of nitrate doubled and the initial rate doubled. So it's a total doubling, so it's a first order. Then I looked at experiment 2 and 3 where these were held constant. Because of that, these two are doubled, and therefore these two are doubled. So again, it's the same doubling effect, therefore it's a first order in both accounts. Go ahead and find the rate constant. I just happen to choose, I think the second one, because I thought the math might be easier. So I put in the rate for experiment number 2, and here is the values. I guess I forgot to put the little m right here. I should have done that. And when I divide it out, I got 0.00027 molarity to -1, seconds to -1. And what's the overall order? The first order and first order up to 2. And why did I put an arrow there? Because I'm showing you that the units are consistent with the second overall order. Okay, let's go to the next question. So here's problem number 8. It says that it's in the order of the first order of oxygen and second order of nitrogen dioxide. And they said, so I just went ahead and wrote down the rate law out of pure habit probably. And then it says, out of each of these initial concentrations, which one's going to go fastest? Well, it really kind of depends on the concentration of your second order, because that's the one it's going to determine really the rate. So I wrote answer C does, because with respect to NO, it's second order, the mixture with the greatest amount of NO will have the fastest initial rate. So that's kind of a straightforward problem. Number 9. Okay, so once again, find the rate law. Well, where is it held constant? It's held constant, right here. So A is constant here, so B doubled, and look what happened, nothing. So that tells me it's a 0 order in respect to B. And 1 and 3 is where B is held constant. So what happened here? Doubled. What happened here? Quadrupled. So this doubled and the rate quadrupled. It's a second order. Okay, so the rate constant, solve for K. I use experiment number 1, so again, I thought the numbers would be easier. So I have 4 times to the -5th equals K times 0.1 squared times 0.1 to the 0. What is this equal to? 1. I can kind of drop that term out. And so I got K equals 0.00400. Well, there's again, look at this unit here. It is consistent with an overall second order. Now, I like this question because it asks something a little bit different. Hopefully you're able to figure this out on your own. So now they're saying, all right, what if we have a fourth experiment and these are my initial rates? What is the rate of the reaction? Well, I know what K is. I needed to K from this problem here and plug it in. Here is my A to the second order. Here is my B to the 0 order. Again, this is equal to 1. I don't really worry about it. So what's 0.00400 times 0.05 squared? And this is my answer. And notice my units again. One of these cancels out one of those. I have meters over second, which is very consistent with the rate unit. Okay, so I like that question. Problem number 10 over here was an interesting one. It's probably one of your harder ones. Now, to begin with, I went ahead, and I found these remain constant, and here this doubled, and here this doubled. All right, so I know it's a first order in regards to iodine. But wait a minute, none of these were held constant. Oh no, what am I supposed to do? Well, I don't know what the order of this S208 is, okay? Now I wrote over here, recall problem number 6. We made this fraction, rate 3 over rate 2, here it is. And what happened? Why didn't I put the other reactant in here? Because if you look back, let's go back and look at problem number 6. Here's problem number 6. We did have a consistent trichloromethane amount. We did have a consistent amount. And so this doubled, but this didn't do anything that we knew of. So I left out this term because they were going to cancel out, because what's 0.02 divided by 0.02? It's 1. So those terms did cancel out, so I left them out. But let's go back to our problem. There is no constant. I didn't keep any of these the same. So I can't just ignore them or cancel them out. I had to include the iodines. All right, even though I know it's a first order, I have to include them because their numbers are changing. So when I plug in these values, rate 3 over rate 2, I could use any of them, by the way. Well, I couldn't use 1 and 2. I could use 3 and 2 or 3 and 1. I picked 3 and 2. So I put the rate of 3 over rate of 2, and I have to include the iodines, but the K's do cancel out. So here is the rate of the iodine times the rate of the concentration of the iodine and the concentration of the S2O8 at experiment 3. And here is the concentration of iodine in experiment 2 and the concentration of S2O8 -2 in experiment number 2. Notice I had to raise them to the x power because I don't know what they are. These are just raised to the first, which is the same number. So if you look over here on the left, this is where I actually did my work. This number right here is 1.01. I'll put a little arrow here. Is 1.01, or it should be 1.1. 0.06 divided by 0.04 is this number right here. And then 0.03 divided by 0.04 is this number right here, but raised to the x. So I divided both sides by 1.5, and I got 0.73. So 0.73 equals 0.75x. If you go back and take the log of 0.73 divided by the log of 0.75, your answer, actually went and figured it out, was 1.09. Really, really close to 1. You could also say 0.73 itself is very close to 0.75. So 0.75 raised to the first power is itself. So we're going to say x equals 1 in this problem. And then so it means it's first order in the S2O8. And now I can find k because I know this number now. So I'll just pick any equation. I picked 2 because I thought the numbers might be a little bit easier. So 6.25 times 10 to the -6 equals k times 0.04 to the first, 0.04 to the first. So I get k equals 0.0039. Molarity to the -1, solve seconds to -1. And notice again, it is second order and the units verify this. Now, problem 11 is a little bit different. I'm hoping you're able to figure it out using the same technique in the last ones. What's different about problem number 11? There are 3 reactants in this case. We have the bromate, the bromide, and the hydrogen ion. So we need 4 experiments to figure it out. So each time we have to figure out where are they held constant. So to find the bromate, I used 1 and 2 because these guys are held constant and these guys are held constant. So this doubled and that doubled, first order. To find bromide, I used experiment 2 and 3 because these were held constant and these are held constant. So this doubled and so this doubled. Once again, it's a first order. To find the hydrogen ion, let's see here. I used, let's see, what did I use? I think I used 1 and 4. Yep, I used 1 and 4. So here, these are held constant, these are held constant, and this doubled, and this doubled. So there again, it's first order and everything. So no, I wrote no third order, watch units of K. We haven't seen a third order yet. So our units are going to be a little bit different. So I just used experiment number 1. Again, I thought the numbers would be the easiest. And so I plugged in the numbers and I found K is to 0.8, molarity to the -2 this time, and seconds to the -1. And I believe that is it. I hope this makes sense. You'll be having bookwork on this at some point. Take care.